from other years. Okay, so on Friday we dealt with vertex form, and vertex form.
Excuse me, interruption with our grade 12 students in classes with teachers with the last name between A and K. Come down with your teachers to get your pictures taken. So we're doing grade 12 this period. So we're going to start off with all teachers with the last name A to K to alleviate some of the congestion. Thank you.
Okay, that's not us. Okay, so in vertex form, just to remind you what vertex form is, it's y equals a bracket x minus k, then the squared plus the h. And what do the k and h represent? The vertex. The h is your x coordinate, the k is your y coordinate, right? Okay, so vertex form shows us something really specific. It shows us the opening, because the a will tell us that. It shows us the width, because the a will tell us that. And it shows us the vertex, right? So there's benefits to both forms. So today we're going to look at standard form, and standard form is this. This is standard form right here. And what does this restriction say?
A does equal 0 to 0.
Okay, so a does not equal 0. And how come? What if there was a value of 0 right here? Would I have an x squared? No, I wouldn't. And therefore, it wouldn't be a quadratic. So it makes sense, but we're going to deal a lot with restrictions. A lot of time they give us reasons, and it's so obvious, but mathematically it's a little bit different to see. Did you have a question?
Can you go back to the top?
Of course I can.
And isn't it supposed to be minus h plus k? Yeah.
Oh, did I get that backwards? Thanks, guys. Ooh, I guess I could have made that h into a k. Let me make it into a k. It's an ugly k, but we get the job done. Thanks. Okay, so in standard form, this tells us the same sort of thing. A still tells us about the width and the opening. So this tells us, the A tells us about the width and the opening. So A does the same thing, doesn't matter which form you're in, it tells us the same thing about both of them. Let me just zoom in here first. Oh, that's very fuzzy. That's better. Okay, and we can find the vertex, but it has to be a find. So we got to do math to find the vertex. Boo-hoo. We don't really want to do that. We got to do math. We can do the domain and range. We can find the axis of symmetry. And the key thing about this one is this is where the y-intercept is. So in standard form, the c, the constant, just the number sitting by itself, is your y-intercept. So standard form tells us the width, the opening, but this time instead of telling us the vertex, it tells us the y-intercept. So it's still pretty useful, and we use this, and we're going to be factoring it to find the x-intercepts. So if we want to find the x-intercepts, we need to factor, okay? So to find the x-intercepts, we need to factor. And this is the form that we factor out of. We factor out of standard form. We can't factor out of vertex form. We have to change it to standard form. I got a question for you. How do I change that into standard form? What does that squared tell me to do? Okay, hold on. So it tells me to expand, then multiply. Do you guys know what that means? to expand and then multiply. So we're going to write that bracket twice. So it's going to be y equals x plus 2 times x plus 2. That's the expand part. That's the expand part. And then we go through and we multiply it. And that 5 just keeps traveling down, and then we're going to combine those. So now this is in standard form. Okay, so if I asked you what are the x-intercepts and I gave you this, you have to get it into standard form before you can go ahead and factor it. Make sense? Kind of makes sense? What?
So I got like, okay, so then it's 4x plus 4, but then it's more like 3 over 2.
What do you mean? Multiply it out. I skipped a step. I think at this point in your mathematical career, if I were to do this on the side over here, if I were to say x plus 2 times x plus 2, x times x is x squared, plus 2x, plus 2x, plus 4. Where am I getting the after number? What's 2 times 2?
4, but, okay, wait, hang on, okay, never mind. You multiply, okay, yeah, got it, I'm sorry.
You good?
Yeah.
Okay, so this is like going back to grade 9 stuff and going back to grade 10 stuff. So if you're not comfortable with multiplying polynomials, me doing it quickly is probably going to mess with your head a little bit. But that's kind of where you should be able to multiply these binomials pretty quickly. This is the leapfrogging that I talked about at the beginning. Okay, so that's how I convert vertex form to standard form. You have to expand and then do your multiplying. All right. Okay, back to the notes, All right, example number 1. Let's talk about the direction of the opening. It's opening up. Good job. All right, now there is a secret formula when you're in standard form that you can use to find the vertex. And it's called a secret formula. I don't know why, well, because I tell everybody, so it's not that secret. But it's not on any formula sheet, so you need to commit to memory of this one.
Isn't it like minus 3 over 2a?
Yeah. And so that gives you the x-coordinate of the vertex. So that's my secret formula, and we only use the secret formula when we're in standard form. Because if we're in vertex form, you just look at the equation and get the vertex, right? Like, it's just right there. In this one, it's not as straightforward. So you want to memorize, get a tattoo of, commit to memorizing that formula. Okay, so it's negative b. So if I look at my equation over here, my b is positive. So when I put it into this formula, what is it? It's negative, so it's the opposite sign. So we're going to have x equals negative 4 over 2 times. And what's the a value? What's the coefficient on the x squared? It's the invisible number 1. So x is going to be equal to a negative 2. Now that's not my whole vertex. What do I need? What do I need when we're talking about a vertex, we're talking about a point on the graph, right? I need my y-coordinate. Any suggestions on how I find my y-coordinate? Any suggestions?
Is it the number 5?
What?
The number 5?
The number 5? No, that's my y-intercept. My y-intercept. You're in the wrong form. But if you were in the vertex form, you'd be correct. So remember that this form doesn't show you anything about the vertex. You have to do math to find it. So in order to find the y-coordinate, all you do is you take this one and sub into equation to find y-coordinate. And you guys know that f of x is, so step 1 is to do the secret formula. Step 2 is going to be to sub into the equation, and that's my shorthand for equation, to find the y-coordinate of the vertex. You guys know that f of x can be replaced with the letter y, right? I can just switch those out. So I'm going to have, my equation was y equals x squared plus 4x minus 5. What do we know x is? Negative 2. So everywhere we see an x, we're going to put in a negative 2. So what's the coordinate of the vertex? Negative 2, negative 9. So like I said, with the vertex, we got to do some math. It's not as easy to find it when we're not in vertex form. All right, let's talk about domain and range. Now, for some of you, if you're not a visual person like myself, drawing the picture is going to help you, and just a rough sketch. So, you know what? I don't think we're going to find the x-intercepts today because we have to factor, and that's a chapter 4 thing. So I'm just going to leave that off for right now. Negative 2, negative 9 is going to be somewhere here, right? Somewhere down here. And which way does it open? Up. How many x-intercepts am I going to have? 2. One here, one there, approximately. So let's talk about domain and range. What's the domain? Yes, negative infinity to positive infinity. And then range. How low does my graph go? Negative 9 inclusive, all the way to positive infinity. So I find sometimes just drawing a rough little graph will help. What about the axis of symmetry? Where do you find the axis of symmetry? Somebody said it. Negative 2, but it's an equation of the axis of symmetry, so what does it need? X equals negative 2. Let's just talk about the x-intercepts for a sec. We're not going to solve for them because that's what we're going to do in chapter 4, and I think I'd just be throwing too much at you if I made you factor. Although this one we could do really easily, and I know where they are. Looking at this, can you guys factor this in your head really quickly? I feel like no. Crazy lady. You will get better at it. What are the factors in negative 5 that add up to 4? 5 and negative 1, right? Yeah? So if it's a positive 5 when it's an x-intercept, we solve for it, so it's a negative 5, and you guys are like, that makes no sense to me, Scallion, but I'll get there, and I'll show you this in chapter 4. So my x-intercepts would be at negative 5 and positive 1. Because if you can factor, you know where the x-intercepts are. Anyway, that's a preview. I won't make you do that, but we can talk about how many. How many x-intercepts? I think we already talked about that. 2. 2 x-intercepts. And then what about the y-intercept? Nope. There is one. -5. And I'll show you that. What do you know about y-intercepts? What's the x value when you're looking for your y-intercept? 0. I don't know who said it, but you're correct. 0. So when we're looking for it, when we're looking for our y-intercept, we know that x is equal to 0. So if you were to substitute 0 in for x into the equation, so y equals 0 squared plus 4 times 0 minus 5, what do you get? -5. So if you don't remember where it is in the equation, you can math it out. You can solve for it. But you do have to remember that it occurs at 0. The x is 0 when you're looking for the y-intercept. I get why somebody said y-intercept of 0 because my graph kind of looks like it is. FYI, my drawings are always terrible. And this was just a rough sketch. This was helping me with my domain and range. Okay, so there we go. We've answered all the questions about it. FYI, ladies and gentlemen, I will be asking you to do this on the quiz. I'll give you an equation and I'll ask you questions like this. Okay, so you need to be able to sleuth out everything I just did. Yep. If you get a formula sheet, all it will have on it is that and that. It'll be the formula sheet that I handed out to you, but it won't have anything labeled on it. You'll have to know what everything is. Okay? So I'm flipping the page. Is everybody good with me flipping the page? Okay, do you guys want me to do this, or do you want to try to do this, or do you want to see it one more time? One more time? Okay. All right. What's the direction of the opening? Up, because the 2 tells us that. Okay, vertex. What do I have to do? I got to use that secret formula again, right? So x equals -b over 2a. I would highly encourage you, and this is how I get good at using my formulas, is that I write them down every time I use them when it's a new formula to me. Because if I write it down, then it sticks in my head. For some people, saying it out loud, it sticks in their head. Whatever works for you guys. Okay, so this time my b is a negative value. So when I put it into the formula, it's going to be positive this time. And 2 times 2. So x is equal to 3. Now remember, that's the x coordinate. What's my next step? So now I got to sub it back into the original. So I'm going to have y equals 2 times 3 squared minus 12 times 3 plus 25. Oh my goodness, I got to do some math here. I'm squishing it in. Do you guys mind if I skip some steps? Like that's 9. 9 times 2 is 18. 18 minus 36 plus 25. Whew. So we have a -18 plus 25. So y is equal to +7. So my vertex is at +3, +7. Sorry, I got really spacey here, and then I crammed all the math into like a tiny little area. Okay, should we draw a picture of the graph to help us with our domain and range? Yeah, okay. I like pictures. It helps me. I'm not a very visual person, so I find that being able to write it down on paper helps me. So 3, 7 is here, and I open up. What's my domain? Oh. What's my domain? negative infinity to positive infinity. Someday you'll all be confident enough to say it out loud. And the range, 7 to positive infinity. Okay, where's my axis of symmetry? What's the equation of the axis of symmetry? X equals 3. See? You're getting confident. I'm just going to draw an arrow to it so you guys know that that's what that is. How many x-intercepts do I have? Go back to my picture. Do I have any x-intercepts? None. No x-intercepts. And where is the y-intercept? At positive 25. So that's not too terrible. It's the secret formula, and the secret formula will not be on your formula sheet, but I might give it to you. I think that's a nice thing to do. Then I won't give it to you on the test. So that's not the nice thing to do, but. Okay, last example. Sorry, you guys are still writing. I apologize. I gotta learn to slow down. Okay, so the last example is kind of a thinker example. It's a thinker example because it doesn't look like everything else that we've done, but you have all the tools to solve it. 1 and 1.5 lies on this graph. This graph here. So this is the point, and it is on this graph. What is the minimum value of the function? First of all, what does that mean? Minimum value. The lowest. And so what's that associated with? Might be negative, but in the example above, our lowest value, are we y's or are we x's when we talk minimums? Y's. Okay, so we're looking at y value. And if it's minimum, if I'm using the word minimum, which way does my graph open? Up. So it's the language. So the minimum value, it opens up. So I'm looking for the y value of the vertex. So right away, as soon as I see that minimum, I know that my graph is opening up and I'm looking for the y value of the vertex. And that's kind of a given in this equation. I have the x coordinate, but I don't have the y coordinate. So if you have a point, where are we going to substitute that into the equation? You guys did this Friday. We're going to substitute those in where we see x and where we see y. So you guys know 3 over 2 is 1.5. Do you guys want fractions or do you want decimals? Fractions? I love it. So do you see how the only letter I have left to solve for is K? I did some math in my head there. That's -1. -1 squared is 1. So now I've got to bring this to the other side, so that's going to make it a subtract. What do I need when I'm subtracting fractions? Common denominators. So if you don't need to show all the steps, I'm totally cool with that. So what's the minimum value of this function? 0.5, 1/2. So you have all the skills, but I think we probably would have struggled with the language in this one. So the language really does direct us in what we're doing. Okay, so that concludes